this is an introduction to 3D in AutoCAD, and wanted to just let you know that in our last assignment we created a template file. Now that template file is probably still your default, so just make sure by clicking on this new drawing icon and then check this dialog box, make sure that the AutoCAD.dwt or the AutoCAD file here is selected for your new template, because when we created the GM template down here, we put all those layers and different scale factor settings in it. It kind of made that one the default when you start a brand new drawing. So go back to the AutoCAD template if you need to start a brand new drawing. Okay, in this drawing I do like to turn off my grid, so at the bottom I'm going to use that. We've talked about that before. At the top left corner, you'll see that there is a top view and a 2D wireframe. And notice here that we are actually in the top view. So if you look over here at the view cube on the top right corner, we are looking down the Z direction, and XY is the plane that we're looking on or towards. So if we go up here to the top left of the screen and we look for southeast isometric, we can go ahead and click on that. You'll see that your UCS icon, its user coordinate system, this icon changes so that now you can see it from a southeast isometric. If you look at the view cube, you'll see that there's south and there's east. So really X is in the east direction. So right now we're in a 2D drafting and annotation ribbon along the top there, the one that we've been using. At the bottom right corner, right next to that little gear icon, there's an arrow, and it gives you this pop-up menu. This is where you can change your different workspaces. And when we pick on 3D modeling there, you'll see that the whole ribbon changes to give us more options in 3D. And notice here at the command line it said WS current. So if you have a Mac, you may have to look into typing in WS current in order to change the workspace. Hopefully you have this icon that you can use to change it to 3D modeling. We're still in the southeast isometric view, and now that we have the ribbon that's set up for 3D, you can see in the view panel we also have here a way to change your visual style. So we're in the 2D wireframe, which is what we set up there at the top left of the screen. But if we want to go to, for example, conceptual, when we click on conceptual, you'll see that the icon changes to a more colorful icon. Your background is black probably, and it might change, but I specifically changed my background to white so that you can see it better on my screen. One way of changing the background, if you wanted to pop over to a white background, is to right click and go to options or type in options. This is only if you wanted a white background. I like the white background for teaching, and also it does help me to see the 3D views, but you can play around with it and decide. In the display tab here in the options dialog box, you can pick colors right there, and then at the top right corner you can change the color for these areas in your program. Okay, I'm going to go ahead and cancel out of this. So you can use this drop down of words to change the different views, or you can use the view cube. So if I wanted to go back to the top view, I could come over to the view cube here and highlight it in blue right there and click, and now we're back to the top view. If you wanted to use the view cube, you can also, under the view panel, change your view. In case you don't have that option in your screen, you can drop this list down and pick southeast isometric in the panel, the view panel there. Okay, we have several different types of primitives, I think they're called, where you can create these shapes that are preset. So if you click on box, for example, and you watch your command line, you're clicking a first corner, you're clicking another corner, and you're pulling your mouse up and clicking a height. So these are all preset for us. We can type in the exact size. Here's a cylinder. We can click a point, pull your mouse out and click, and pull your mouse up and click. This is one of the assignments. It's an assignment that ends up with a lot of different things that you're working with to get used to the 3D world. So save the file. This is starting from scratch, right? That AutoCAD template. But you're going to go ahead and save it. You put it in one of your folders and name it so that you can submit it as an assignment for this class. So as we're working our way down, why don't we go ahead and draw each one of these just to see how a cone is drawn. And basically you're clicking a point because your command line says center point, and then maybe it says radius for a sphere. So this is kind of fun because we know that we can create a pyramid and a wedge if we need it for our project, and also a torus. A torus will give us the outside ring or radius of the actual torus, and then the tube radius here. So I'm going to go ahead and click for the tube radius. Okay, so as you're drawing these shapes, you can see that you're drawing on the XY plane or surface. If you hold your shift key and the wheel of your mouse at the same time and move your mouse around, you're orbiting around in space so that you can kind of dynamically see here the different objects and different views. And if you don't have a mouse that has a wheel, you can always come over here to the navigation wheel, which has here orbit, and hold that down with your left mouse button. Or I'm going to close out of that. One of these commands here, this one here, is orbit. And underneath orbit, it has other options: free orbit, continuous orbit, other options for us. Well, actually, I will show you this because continuous orbit is kind of cool. If you hold your left mouse button down and drag it and let go, you can kind of create this little continuous orbit so that you're kind of seeing it rotate. You don't want to leave that on too long. I understand it might take up some of the RAM or mess with the files, and you'll have to take a look at that. But I think that if you want to orbit around an object and you want to just see it in this way with hands-free, you can use this continuous orbit and then just escape to get out of it. Once you do that, you're in this kind of odd view. So it's a custom view. You can go back up to the left, top left here, and pick Southeast Isometric, and it'll bring you right back. Okay, so we're drawing in the XY plane. So over here in the draw panel, we can use these tools like drawing a regular 2D geometry, like a circle. So I'm going to go ahead and draw a circle. And notice what happens when I draw the circle. When I draw the circle in space, it actually draws the circle right on the XY plane. But by default here, when you start that same circle tool, if you go on top of one of these faces of either the side of a box or the top of a box, you'll see that the UCS icon kind of rotates temporarily, so that now as long as that face is highlighted and I click, I can draw right on the side of the box right there. So I just drew a circle on the side of that box. And so there are opportunities to draw beyond the XY plane in this way. One of my favorite tools is called Presspull. With Presspull here, I'm going to go ahead and click on it. I can go right inside that circle, and not on the edge of the circle, but right inside of it until the circle's blue, and click. And when I pull my mouse away from that face, I will create a solid. But if I pull my mouse back into the shape and click, I'm going to subtract it. So I'm going to hold my shift key and my wheel of my mouse and orbit around here and see that I just created a hole. So this is kind of cool because now we can draw right on the face of an object and then use Presspull to kind of cut out what we don't want. I'm going to use my escape key to get back to the command line here. And maybe I'll pick up now the midpoint object snap. If you don't already have it on, you can go down to the bottom there, pick up here where we learned about object snaps, make sure midpoint is checked. And now I'm going to draw a line, just a regular line in the draw panel, and I'm going to make sure that this face is highlighted, and then click the midpoint here. And I'm going to make sure that I click here the midpoint on this side and enter. And now if I use Presspull and I get inside the triangle and click, I can pull my mouse out and click and kind of cut out that piece. We also have these commands like solid union and solid subtract and solid intersect. So union, the objects touching each other will become one, and subtract, you're subtracting one object from another. You can see the little display showing you that. And then intersect is whatever's common between the two, and this can be very helpful if you want to create two different surfaces or profiles and then end up with the difference between those two profiles. So for this example, let's draw a box, and then we'll draw a cylinder right at the corner of that box. So here I'm going to draw a box by clicking 3 points, and I'm going to draw a cylinder by clicking the corner, the front corner right there, just to make sure that it's next to or inside the box at some point. And then I'm going to establish a radius and a height right here. It doesn't matter how high it is. On your example, we're just kind of like looking at the tools. These two 3D solids are separate, so now we want to subtract one from the other. We're going to subtract the cylinder from the box. So I'm going to go ahead and pick the solid subtract right here. We can select the box first and then enter, and then click on the cylinder and enter. You see how it kind of takes it out of that space. Even after drawing these shapes, you can click on the shapes and use these little grips, these little triangular grips, to change here the radius or even the height of the object, or use Presspull to change how high the cylinder is. The objects that you select will have this bigger XYZ arrows, and those are going to help you to move these objects within the X, Y, or Z direction. So select the cylinder, click right on the blue arrow, the bigger blue arrow that has a line in it right there. Pull your mouse up and click. What you'll see here, if you escape out of that, when you hold your shift key in the wheel of your mouse, you'll see that you move that cylinder up by using those arrows. So if I select it again and I click on this red arrow, I can move it in this direction here along this tracking vector to move it along the X axis, and know that I've moved it along the X axis. I could even type in a value if I wanted to move it a specific distance. Now if you have an object selected and then you use orbit, when you hold your shift key and your wheel of your mouse, you see how everything else kind of turns off, right, temporarily when you're in orbit. So if you want to see everything, use your escape key to get rid of the grips in order to get back to orbit the entire drawing. So I'm going to go to the top view, and by going to the top view here, I can go to customize view, custom view, and then pick top. I'm going to now draw some kind of shape that's a closed shape with just regular lines. So just regular lines, go ahead and draw whatever shape that you'd like to draw. It doesn't matter what it is, just make sure that you close it, pick close in the command line there, or click back the first point that you picked to make sure that it's closed. And now let's draw a second object that way. So we're drawing 2D here, geometry, but this time same thing, we're going to use a line to draw this closed shape. Now let's go here back to the southeast isometric view, and I'm going to orbit around to that view so I can work with it. What I'd like you to see is that when we use Presspull, which is one of my favorites, I told you, and we can get right inside this shape here until it changes blue because it's recognizing the boundaries, and then click in order to create your solid, and pull your mouse up and click for a height. But when we use extrude, which seems at first to be the same, we don't actually have boundaries to select. So you're not inside the closed shape. And if you do select all of these objects to create an extrusion, you're only going to get the surfaces. So before you use extrude, we have to use a couple of different things. We either have to join these lines so that they become polylines, or we can create a region. So we'll do both. First of all, you really need to have a polyline. So let's say these are lines and they're separate lines, right? But what if I have a polyline, like a rectangle? A rectangle is a polyline. So if I draw a rectangle, a 2D rectangle out here in space, and now we use extrude to select that rectangle and enter it, it will create a 3D solid because that was a polyline. And in fact, you could have drawn an actual polyline in order to use extrude to extrude the object. But another way would be to create a region. So in the draw panel, right underneath the word draw, you'll see that the command is here, region. You can also type it in at the command line. So select the region tool and now click on all of these single lines and enter. And now it creates a surface, right? So it's taking all those individual lines and creating a surface that now we can use extrude to extract and create a solid shape. So here I'm going to use extrude to select that surface that was created with a region and enter, and then I can use extrude. Now, kind of the nice thing about extrude is that it does have extended options in the command line, like tapered angle. Tapered angle is important if we want to taper the base here up. Now I noticed that if I went into my command line to pick tapered angle, it's going to go down. So I want to pull my mouse up and type in T for tapered angle and enter. And now you can see already that all of the sides are tapering. So now you can establish the angle of your taper. And so maybe this is 50 degrees and now I have the tapered angle, and now we want to establish the height. I just clicked for the height. So if you use the extrude command, make sure you have a polyline. If you don't have a polyline, you can use region. So I'm going to explode here this extrusion. That's not something that we want to always do, but once in a great while, I do need to explode a 3D model. Keep in mind that it's not something we want to get into the habit of, because now when you explode a 3D model, it goes back into surfaces and now it's empty. It's not a model anymore. So if I explode, I can use here the tool that's right underneath the word modify. Here's explode. And I'm going to go ahead and select this extrusion and enter. You see how each one of these pieces now, I want to show you this, becomes a separate object. If I take this out, this surface out, see, it's empty. If I erase these pieces, then you'll see that they're individual pieces. Just want to show you that you don't want to explode your extrusion. When you use press pull, in this example we worked with earlier, the solid shape is separate from the original line work. And extrusion, you can see over here, consumes the line work. So let's say you've got some 2D geometry and you're ready to make it into a solid. If you use press pull, the 2D geometry will still be maintained. If you use extrude, the 2D geometry will be consumed with the command. Okay, so what I was getting to is being able to join these lines to make them into a polyline, so you can use the extrude command. I just use press pull, but it's good to know all of these things, I think. The polyline edit command is pedit. You can type in pedit. I believe the icon is underneath modify there if you're using icons. And there it is. There it's a little pencil icon. It's pedit or edit polyline. If I select one of these lines, my command line will ask me if I want to turn it into a polyline, which I do. So I'll press enter to say yes. And then I'll pick the command join. Join is going to let me select all of these lines, even the original one if we want to. As long as they're touching each other, we can select all of those lines and press enter. And enter again. It says 4 segments added to the polyline. Now that it's a polyline, I can go up to extrude and select that polyline and enter it and create here an extrusion. So just wanted to point out to you the differences there between extrude and press pull. We will be covering loft, revolve, sweep, and a couple of other features in an assignment next week, and wanted to get you started with some of the basic functions of 3D in this introduction assignment. Let's take a look at creating a fillet and a chamfer to one of these edges here of this box. If you don't have a box, go ahead and draw one. We can use the regular here fillet and chamfer tool, and that's what we'll do first, but there's another more advanced fillet that's over in one of the other tabs. Here, let's just go ahead and click on fillet in the modify panel, and then click on the edge right here that you want to fillet. You see how it turns blue? And your command line says enter fillet radius. Well, it depends on how big your drawing is. If you are drawing huge shapes, then you might want to create a bigger fillet. So I'm going to try 1. Type in 1 for the fillet radius, and then enter again. Enter a second time when it says to select an edge, because you already selected the edge. And there's your fillet. You may need to use 0.5 or 0.25 if your box is really small. So if it doesn't work, just do it again and change your fillet. So let's take a look on the back side of this box here. We'll use the chamfer command for this edge. So we'll go up to here, chamfer, And just like the 2D chamfer, we have two sides and we're creating a distance from those two sides or those surfaces so that we can create this diagonal like wedge cutout. So I'm going to go ahead and select here this edge. What happens is AutoCAD selects that this surface for the first dimension or the first surface that will be modified. So I need to press OK to accept that. Now if you look at your command line, it says base surface chamfer distance. I'll type in 0.5 because it's going to be for this surface. It's going to cut back 0.5. And then the other surface, which will be the top surface, maybe we'll use 1 just to show you the difference, and enter. And now it's asking you again to select the edge. I'm going to select this edge. It doesn't look like it's selected, but it is, and then press enter. So if you think about the steps, you're selecting an edge to tell AutoCAD what two surfaces you're working with, and then establishing a distance from that edge that's selected, a distance from the corner back to where you want it to be cut. And then the second chamfer distance is from the corner back to where the other surface needs to be cut. So when you take a look at this, you'll see that there's a smaller surface here that was cut back and a larger one here based on the 0.5 and the 1. So that's the chamfer, and we do have those in assignments coming up. Another very helpful tool is called 3D Rotate. 3D Rotate will take this entire model that we select and rotate it 90 degrees or however you'd like to rotate it in the 3D XYZ planes. So I'll go ahead and click on 3D Rotate. I'll select here my 3D solid and enter it. And now it's asking for a base point. So the base point is where you want to start this rotation. And it's going to put these rings at that base point. Now your command line is asking you to pick a rotation axis. So notice that when I get close to the red ring, my axis is going to be in the Y direction. And if I pick the blue ring, it kind of turns yellow and becomes the Z axis. So this whole thing would rotate around that axis. So I'm going to go ahead and get close to this green ring. The ring itself turns yellow, but you'll see that you have the green axis line right there. And then if I type in 90, I can press enter, and the whole thing is going to rotate 90 degrees down. Another way to work with 3D Rotate is to rotate an object dynamically without a specific angle. So let's do that again. Start the 3D Rotate command, select the object and enter it, pick a base point, pick an axis, a rotation axis, and then pull your mouse straight up to establish the angle that you want to start with instead of typing in 90. You see how when I move my mouse, I'm able to dynamically pull here my pointer around and pick whatever angle I'd like. So if I need to line this up with some other object out here, I can snap to it so that it has that specific angle. I just went ahead and clicked for a different angle. Sometimes the UCS icon gets rotated and we want to go back to the AutoCAD default. If you look under coordinates, you'll see this world icon. It looks like a little earth. That's the icon to click on. It will bring you back to the default X, Y, Z. You can even type in UCS and then enter, and notice that world is the default, so you enter again and it'll go back to 0, 0 and go back to that default point right there in case this starts to rotate around. In the next assignment, we'll take a look at how we can work with this a little bit more. In this assignment, we're looking at some of the basic tools as an introduction to 3D solids. You can see here in the modify panel that we have 3D align and mirror and scale and rotate. We even have 3D array, which isn't in here, but you can type it in. And then in the solid tab, we have a lot of other tools and things that we're going to be taking a look at. But if you pick the solid tab, you'll see that here are primitives I was talking about. There's press, pull, and extrude. Here's Boolean commands, union, subtract, and intersect. We even have fillet and chamfer here as an edge. Okay, let's move forward with another assignment to put this together and apply it.